Hello, welcome to an APH virtual, it is virtual, Access Academy. This is getting started with tactile algebra tiles through students' eyes. I am so glad you're joining us, and welcome Nabiha and Robin. I will let you get started.
So hello everyone, my name is Nabiha and I am the TVI. I'm also a VI regional sports specialist in Louisiana. And we also have Robin King with us. Robin, you're muted.
I'm sorry, I forgot to unmute myself before I started talking. Welcome to our presentation today. I was excited to see there were teachers here, so we hope we gave you some ideas for that. But my name is Robin King. I'm the director of the Instructional Materials Center for Louisiana, and I'm the ex officio for Louisiana. So welcome to our presentation today.
We also have some student presenters with us. We have Brianna and we have Wyatt. So Wyatt goes to Louisiana School for the Blind, and this is his first year there. So he comes from a very exclusive classroom.
And Brianna is with us, and she's a student at LSVI as well. And she's been at our school since 3rd grade. So we're very excited that both of them are being a part of this with us.
Thank you, Brianna and Wyatt. So for our learning objectives, I will go through this very quickly. So you will be able to learn the basics of using tactile algebra tiles to represent numbers and variables. We will also use these to show how to add and subtract integers. Along with that, we will also try to model how to simplify algebra expression using these tactile algebra tiles. And lastly, we will solve simple linear equations with our tactile algebra tiles. So what is tactile algebra tiles? Because I didn't know about it when I was my first year TVI. I didn't know what it was, but now I do, and we do want to go ahead and explain what it is. So before we talk about it, let's talk about the concepts of just having those math concepts there. So why do we need to use it? Research shows, and there's a lot of evidence that students who are blind and people who are blind or they have low vision, they tend to rely on their memory skills a lot. They memorize math. And if you look at a student who grew up memorizing math, and you look at a student who grew up understanding the concepts behind it, having that math sense, we can see how students who grew up understanding the math concepts, they tend to have a better experience. That's what research shows. And the most recommended way to develop those concrete form is through manipulatives. Robin?
And another reason it's so important to have tactiles for students who are visually impaired and blind. Our students have an opportunity to explore when you're giving them a concept, instead of seeing it one part at a time, they're able to use tactiles to develop that spatial and directional concepts that are so important to learning for them. And when everything is in place right, when the teacher is doing proper instruction and the student has accessible materials, then the next thing in their tool is to have the curriculum, the materials they need. And research supports that 10 out of 12 students are going to be successful with that. So that's our hope in doing this presentation with you today, is for you to understand why it's so important for you to give this to your students.
So when we use these algebra tactile tiles, it helps us develop those concrete ideas from abstract ideas. So if you think about it, numbers is such an abstract idea. What is 2 plus 2? But when you use manipulatives, when we use tactile algebra tiles, it helps us develop those concrete form. So when a student solves an expression or an equation, that's abstract. But when they use manipulative, it becomes more concrete. And these tiles have a very universal design. They come in a very accessible format that Robin's going to describe.
Yes, part of the UDL that everyone knows about. And I'm excited to see some college staff, professors were on the survey. It's so important that the VI field for educators to understand that designing the instruction at the very beginning to be inclusive for all students brings about success. So this tool of this tactile, the algebra tiles, will absolutely be a tool that you could use in your UDL as you design what your math program is going to look like. I believe that any student could benefit from having access to these tiles. The other thing about that is, we talked a minute ago about the spatial understanding, but the most important piece of this is a student's own self-esteem and how they feel about math. We want it to be a positive experience. We want them to feel like they're able to understand a concept and then master that concept on their own independently. So we believe in these tiles and we think it'll help support that for your student.
And just piggyback on what Robin said, one last thing I want to say is all the research. So I'm a grad student, so you know how we're heavily based on the research. You want to say things that research proven. So there's so much research on a direct correlation between a student's success and their self-esteem. As they feel successful, their self-esteem, it becomes better. So just wanted to say that. So enough about the background and the concepts. Let's actually talk about what comes in the box, because I was very interested in it. So I do want to say that this is not something, as a TVI, you're not supposed to use it every time a student is solving an expression or an equation. It's just to develop those foundation. And once the foundation is developed, you can stop using them. But it's not something that you have to use for every question. I just want to say that. But Brianna and Wyatt, would you like to talk about the various colors and the textures and what comes in the box? Why don't you go ahead and talk to us about that?
So there are multiple shapes. There are rectangles. There's a big square and a small square. The big square represents X squared and the rectangles represent X. And the smaller squares represent 1. But there's 2 different bags. The red ones will be your negatives. And the other colors like the purple, the blue, and the green represent the positive numbers.
There are also different textures to the tiles. So the negatives have bumps, the small square, the 1 integer, the negative has a singular dot, and the positive one has a outline of the square. And for the X, which is the rectangle shape, the negative has 4 dots in a line, and the positive rectangle just has that outline of the rectangle. And for the X squared, the negative has a square of bumps, so like bumps just in a square, and the positive has that square outline, bigger, a way bigger square outline, so they're accessible for people who can't see too.
So I just want to combine what Wyatt and Brianna said. Wyatt said red color, and Brianna said, so red represents negative, and Brianna, negative for you is, how can you differentiate that?
The dots, the ones with the dots.
Very good, the high risk, yes. So you can tell red, high risk dots, negative, we're just using different terms, but a student like Wyatt who has low vision, or a student like Brianna who's blind, they can still understand the concept. So me as a teacher, if I'm like, hey, take the red tile, Brianna still knows what I'm talking about. Do you, Brianna?
Yes.
Okay.
So
Because sometimes when you're talking, you're teaching, you're just in the middle. You don't like just stop and ponder, oh, should I say high raise or red? When you're just talking, in the session, you just say it. You just say red tiles sometimes. Sorry. So do you want to go ahead and model something for us now? Do you want to, like, I think enough about the concepts and the unboxing. Oh wait, is that all that comes in the box? Just the tiles? Is there anything else that comes in the box?
No, there's also a line, which is the divider for when you get into your like distributive property or 1 and 2 step equations. It's like the divider.
Like an equal sign, yeah. And then also comes the board. We have 2 boards that come in the box as well that Brianna and Wyatt are working on. Something about the board, Wyatt, do you notice something about the board? Or Brianna, any one of y'all?
The board's magnetic.
It is. Okay. So, okay, let's just start. Let's just model something simple. We're gonna start with something really easy, really simple, so y'all can get that feel, warm up. Let's do 7 plus 3.
So
Can you
just
model
getting
7 plus 3 using your tiles?
yeah, I'm getting the tiles right now.
The students are
And
trying
I just
to.
like to say that students are taking tiles out of their bags and they're placing them on the board.
Brianna, I'm sorry to interrupt, but can you feel your negative tiles? That is something that I can see. So the top corner that you're working on, I cannot see that. I can see that, yes. So you can, do you mind removing that?
Okay. There we go.
Thank you so much.
So Wyatt has his board set up with his 7 plus 3, and Brianna's still working on hers.
So why do you want to talk us about it?
So I have 7 tiles, and since problem 7 plus 3, I have 3 extra tiles, and what I can do is I can take these 3 and add it to my 7. And so if I want to find my answer, I can count 7 and 3, which would give me 10.
And I'd like to add that Wyatt was using the small green tile to demonstrate that.
Brianna, would you like to talk to us about it?
I have the seven tiles. And then I have 3, and I'm just going to take these 3 and add them to the place where my 7 tiles are, and then it makes 10.
Perfect. All right, that was way too easy for y'all. Let's put some negative in there. So let me go ahead and give you a new expression. Let's do.
So Nabiha, before you do that, they set those tiles up different. One student set them up almost in columns going up to the sky, and another set them going across. Did that matter?
Brianna, White, would you like to answer that question? Thank you, Leanne, for bringing that up.
For me, the way I like to do things, just for my personal style, I'm try to keep it organized and the best, just so it's easier for me.
That's a great answer.
Yeah, it's still the same thing. It's just I like.
Yeah. So no, it doesn't matter.
Yeah, it doesn't really matter because every student does organize materials the way that's best for their learning style. And I also want to add, as a VI teacher, you'll want to decide if you have a younger child, do you want to have the Brailler there as well? I mean, and think about reading Braille, like creating the sentences, that could all be part of what your design is. But for today, you know, we're just showing how to use the tools. I don't want you to think that you don't have to Braille the materials out and learn how to do the problems that way too.
Okay. So let's go and work on the next problem. Let's say -6 plus 5. And Brianna, there is a braille writer right next to you. Am I correct? On your left or right hand, if you want to use that. Feel around. So the next problem is -6 plus 5. I know it's an easy one. So can you model out -6 plus 5, please? So Brianna is removing her positive tiles, +1 tiles. And she's feeling her bag of negatives, and she's taking out the negative tiles. Brianna likes to keep her tiles in the bag, but Wyatt likes to kind of have it all out. He's very chaotic in that manner. But Brianna likes to have it all organized in a bag.
Okay.
This is -6 plus 5. You can talk to us about it, Brianna. Can you explain what you're doing?
So I have my -6 in a row, kind of going up and down. And then I have my +5 tiles on the right side of that. And what you do with them is you pair them up because a negative plus a positive equals 0. So when you pair them up, then you remove them from the board because that's 0. So you just slide them together and that makes a pair. You remove them from the board. And then you're left with -1.
Okay. And then I'm going to describe why don't you describe what you did? So Brianna was pairing them up. She was bringing the negative tile and the positive tile together. She would somehow make them touch each other, and then she would slide them off the board. She was very organized in that manner. And what about you, Wyatt? What did you do very quickly?
So what I did was I took my positive tiles and covered my negative tiles.
So I saw you putting it on top of each other. You place the negative tiles on top of your positive tiles. So it's a different manner, but there's still, what did you end up? What was your solution you ended up with?
I ended up with -1.
-1. So even though they used different method to pair the zeros up, they ended up with the same solution. Okay. I know y'all, it's really easy so far, but we're gonna notch it up in a bit, okay? So let's move, that was adding integers. Let's go ahead and subtract integers. So I'm gonna give you something really simple. Let's do, you wanna do 8 minus 3, something simple like that. Let's do 8 minus 3. So how can you model 8 minus 3?
So we're going to take our positive tiles, or this is what I'm doing, and I'm just going to put 8. So 1, 2, 3, 4, 5, 6. Hold up. 6, 7, 8.
Brianna, would you mind moving your work a little bit to your right? Oh, perfect. Thank you. I can see it now. Thank you. So you're just counting the tiles right now. You're bringing 8 positive tiles. Got it. And so is Wyatt. Wyatt is doing the same thing.
And then you're going to take 3 negative tiles, put them right here, because -3 is the same thing as doing +-3.
Very good. I love how you rewrote that expression. I have a hard time with rewriting it because I grew up without all these terms. So 8 plus -3, good. So you change it into an addition quotient. And then
you pair them up. Divide them off. And
so Wyatt, what are we left with? Because Wyatt is not talking right now. So Wyatt, what are you left with?
I am left with 5.
Very good. So that's our solution. Let's go ahead and move along. I know these are very simple, but we're trying to understand the concepts right now. Let's do -8 minus -4. So go and write it down, braille it out. -8 minus -4. What are you starting with, Wyatt or Brianna?
-8 tiles.
Very good. I'm starting with 8 negative tiles, and so did Brianna. So what's next? -8 minus means what? -8. We're taking away what?
We're going to take away 4.
What kind of 4?
I'm going to take a -4.
Good. So -8, subtract, take away -4.
just gonna
So you have your 8 displayed, Brianna, and now you're doing what?
you're just taking 4 of those tiles and removing them off the board.
Good. So Brianna just had her 8 negative tiles displayed, and then she removed her 4 tiles, which is off the board. And what are we left with?
Nabiha, I have a question.
Yes.
Why did she remove tiles instead of pair tiles up?
That's a good question. Would you like to answer that?
For this one, since it's just -8 minus -4, since we know we're subtracting, and it's minus -4, while you could do like the plus 4, it can just be easier to just, since you know you have negative, you're subtracting negative, to just remove them from what you already have.
Because the negative tiles are already there. Well, how can you we're taking away what's already there, the negative tiles. Why would you like to add that?
No, I don't know what that's about.
Covered it all. All right. So I think we're good with the modeling integers. Simple adding integers, subtracting integers. So let's go notch it up a little bit more. Let's go ahead and do polynomials. Let's go simplify algebraic expressions, simple expressions. All right, so let's model something simple. -3x. What do you want to do? -3x. Why, Brianna, give me a number. -3x minus 7. Let's do that because everyone is scared of negatives.
Negative, oh wait, no negative? Wait.
-3x minus
Neg-
7. So thank you, Riot, for writing it down because I'm gonna forget about it.
-3x minus 7.
Good, Brianna.
So then we're going to take 3 of, okay, we're gonna take 3 of our rectangular negative x's with the dots.
Very good. So you took your rectangular tile, which represented x. Very good job. And how many did you take?
3 for the
Very
3x. And then minus 7. So we're gonna do
What are we doing, Wyatt? You're so quiet today. What are we doing, Wyatt? So Brianna just set up her 3 negatives, and what are you doing?
I'm setting up my 7.
What kind of 7s are there?
Negative.
So what's another way of rewriting this expression? Can you think of that? What's another way of writing negative 3x minus 7?
Negative 3x plus negative 7.
Yes, good. And can I simplify that? Can I simplify that expression?
No, you can't.
No?
Yeah.
Why? Why can I not simplify this model?
There's nothing to simplify.
Hmm?
There's nothing to simplify.
Why can I not simplify? What do I need to do in order to simplify?
You need to pair things up. There's nothing to pair up.
Very good. We have to pair it up. Do I have anything that I could pair them up so they can end up with a zero pairing? No, I
No.
see why nodding his head no. That's correct. Okay, so let's go ahead and do something more intense than this. And let's do 5x plus 3. Make sure you always write your, I thank you for writing your equation, your expression. So in a perfect world, I should have given you a written out, but that's no fun. So it's 5x plus 3. Brianna, why didn't you write down your expression, please?
Oh, I did.
Oh, sorry, I didn't hear the writer. I'm sorry. So it's 5x plus 3 minus 2x minus 4. 5x plus 3 minus 2x minus 4. Let's model this expression out.
So I'm going to take 5 of the positive x's and put them x.
And then Brianna is recounting her x's right now, her x's tiles. So where's wide? And then
Plus
wide, what did you do after you placed your x's tiles?
I placed 3 of the pen.
Okay. And then are you done? You're just like sitting there wide? Are you thinking? I'm sorry, I'm gonna let you think. I'm sorry, I'm gonna be quiet. I'm gonna give you like 30 seconds to ponder. Five x plus 3 minus 2x minus 4.
But Wyatt and Brianna both are taking tiles and they're organizing them the way that they like to learn and placing them on their board so they can solve this problem. So give them a few seconds as they do that.
Why is still thinking about it? Okay, good job, Brianna. I see that you have your 5x tiles, you have your 3 integers, and then what was the third step you did?
and then I put 2 negative -1 tiles because the -2 and then -4, so I put 4 more negative tiles.
Okay, I can see why putting different types of tiles. So Brianna, what kind of tiles of negative tiles did you just place?
Oops, I was
What
wrong. I
happened?
didn't see
Huh?
X. Okay,
What did you explain it to me, please?
I didn't see the -2x. Yeah, that was my fault. My mistake. Oops.
So Brianna ended up putting just a simple mistake because we have been working with integers for so long. She forgot to put her x tiles, which is absolutely fine.
Yeah, I fixed it.
So
There we go.
Brianna or Wyatt, what do you have now?
I got 5 positive x's with 3 positives, 2 2 negative x's with 4 negatives.
So we haven't modeled out. Good job. Almost good job, I guess. I'm not impressed yet. So what do we do now? We have our model there.
So now to simplify it, because this one we can simplify, you're going to pair things up. So you can pair the 5x with your negative 2x. So you
So the whole 5x? I'm pairing the whole 5x, Brianna?
No, you just pair the ones. So you just do negative 2x with positive 2. So
Okay, good. I'm pairing them up. Yes. I'm sliding them off.
which leaves you with 3x. And then you're gonna pair your ones. The ones that pair, which leaves you with
Brianna and Wyatt, they're pairing their positive x's with their negative x's, and then right now they're pairing their negative integers with their positive integers, the ones.
yeah,
And then-
which leaves you with 3x plus negative 1 or minus 1.
Good. So I love how you told me this both expressions. So you left with 3x plus negative 1 or what else, Brian? Wyatt?
Or 3x minus 1.
Perfect. All right. So good job with simplifying your expression. Let's go ahead and do something like, let's work on distributive property. I don't know. I do a bad job pronouncing the name. So let's work on distributive property. So let's work on the question 6 times the quantity of, I'm going to give you some time. I know you're cleaning your boards up, so. All right, so 6 times the quantity of x plus 3. So 6, open parentheses, x plus 3, close parentheses. Brianna just finished drilling, and now she's looking for her tiles. And Wyatt just finished writing it down.
Can you repeat it for me?
Yeah, it's 6 times the quantity of x plus 3, or 6, open parentheses, x plus 3, close parentheses. Brianna is thinking, she's making a thinking face.
Okay.
So I know that x is being multiplied by 6. Let me walk you through while you're thinking. So there are how many x plus 3s, if that helps?
There's 6.
Very good. So there's 6 groups of x, and then there's 6 groups of 3s. So, okay, I see Brianna and Wyatt putting out 6 tiles, 6 x's tiles, 6 tiles of x. I'm struggling.
Yeah, x's, and then 6 groups of 3.
Oh, y'all went ahead. Okay, so good. So what they did was x, they showed x tile, and then they put 3 integers there. 3 1 tile. And now they went ahead and they started grouping them up. So they put 6 x's, and now they're putting 3 tiles with their x. 3 tiles of 1s with their x. Why don't you explain? You explain it better than I do.
Yeah, so I put my 6 x's like in a row kind of across the board. And now I'm putting 3 groups of, I'm sorry to say that. I'm putting Words are hard. I'm putting a group of 3 tiles under each X. That's the right words.
Very good. So you're putting 3 tiles? Okay, got your mistake. You're putting 3 tiles, Brianna? Are there 3 tiles there?
I'm putting
Okay,
3
now you're
tiles.
doing it. You fixed it. So let's look at these tiles as this one thing, as a one model. What do we end up with?
You end
And with 6 X's and 16 of the small green tiles.
6 X's and 18, and I'm gonna let White count and Brianna.
9, 12, 15, 18. 18.
18. So what's gonna be our end? What's gonna be our solution?
So the solution is 6x equals 18. Wait,
Plus,
no. Okay. So you have to put.
no, you're right. It's 6. That's it. We're distributing, so it's gonna be, my final solution is gonna be 6x plus 18, and that's
Yeah.
it, right?
Yeah.
So let's move on. Let's do the opposite of distribution now. Let's go ahead and factor. Let's go ahead and factor polynomials. All right, are you ready for that?
Okay.
Thank you, Brianna, for writing your answer, your solution. So let's go ahead and factor 8x plus 2. So now we're doing the opposite of distribution. Now we're just gonna factor this expression out. So we have 8x plus 2.
So 8x.
So Wyatt and Brianna are modeling 8 of the x's. Brianna already have her 8 x's out. Wyatt is cleaning his board off. 8x
Plus 2.
plus 2. So, is there a way I could split this model equally?
Yee.
Okay.
Yep.
How can you model that out for me, please? Well, Wyatt, I see your 8 x's. What about your 2? Do you have your 2 and I just cannot see it? Thank you. Oh, whoa. Okay, it went quickly. What are you giggling about?
Okay.
So Brianna is counting her tiles. She's counting and she's trying to make them equal. She's splitting them up. Okay. And
Here we go.
here we go. What?
So what I did is I put one of the tiles on top and then 4 x's under it, and then the other tile and then another 4 x's. So now it's 4x and 1.
Very good. So we have 4x plus 1. Yes. But then how many groups do we have?
Yeah, it's 2. So 2 times 4x plus 1.
Very good. So it will be 2 times the quantity of 2 open parentheses. 1, 2, 3, 4. 4x plus 1 close parentheses. So that's the opposite of what we did, distributive property. So that's how you're gonna factor it. And once again, to check yourself whether your factorization is correct or not, I use distributive property. All right, very good job. So let's go ahead and work on solving some simple linear equations. Okay, are you ready to do that?
Yee.
Clean your board up. So let's work on x minus 6 equal, let's pick an odd number because I like odd numbers. X minus 6 equals 11. So notice now this time we have 2 sides to the equation, which is separated by like an equal sign. x minus 6 equals 11.
Okay.
Minus 6 equals 11. Why, do you mind moving your board a little bit to your left, please, so I can see the whole board? Thank you. So Wyatt, can you tell me what the equation was, please? Can you repeat the equation to me?
X minus 6 equals 11.
And can you explain the tiles you have displayed on your board?
Sure. So I got one of the rectangles, which represents X, and I got 6 of the green one. Then I have
And what does
11.
green represents? What kind of green tiles
Green.
represents?
The positive ones.
Okay, so we have, what was the equation again?
X minus 6 equals.
Okay, and then how many tiles do you have on your board?
I got 6. I got 6 of I got 6 for the 6. Then I have 11 on this side for
What kind of 6 tiles do you have?
positive.
Positive? And then what was the question again? Brianna, why are you giggling? Why are you giggling, Brianna?
It should have been negative. Negative.
So what did you
It was-
hear? What's Wyatt doing?
It was x minus 6, which is the same thing, because this is how I remembered it, x plus negative 6. So you would use the negative tiles, not the positive one.
Okay. Why the box is underneath the board? See if the dividers are in the box. Okay. Okay, so why don't you explain what y'all did, please?
So I have my x, my positive x rectangular tile thingy, and then I have my negative 6 tiles right here, and then I have
Here where,
oh.
Brianna?
Okay, sorry, by the x.
You don't have to apologize.
Okay, so by the x, I have them by my positive x. Then I have a line, the divider separating it, and then on the right side of the divider, I have 11 tiles to represent equals 11. 11 positive tiles.
Okay, good. And so does Wyatt. So Wyatt, do you want to tell me how we can what's gonna be my first step whenever you have one-step equation? What's my first step? Do y'all know?
To isolate the
Yeah, very good. We have to isolate the variable. And how do why? Because you're not talking, so I'm gonna make you talk. How can I isolate my variable?
Well, you can add 6 positives to remove 6 negatives.
Very good. So I'm adding 6 positive tiles on my left side. So Brianna, what do I do when whatever I do to one side, what do I do? Or Wyatt, either one.
You have to do it to the other side.
Good, yes. So if I add 6 tiles on one side, make sure I also
add them
6
on the
tiles to the other side.
Oh, Wyatt did that already. Did you add? I missed it. Oh yeah, you did. Okay. Okay, Wyatt, you were about to put a negative tile on your other side. I was like, oh, Wyatt, I had to pick on you again.
Oops.
So they're just working on their, they're adding, how many tiles are we adding?
6.
They're adding 6 positive tiles on both sides right now. So they're just counting it out. So once you added the 6 tiles on both sides, what do we do?
Then you're going to pair the ones you need to pair up. So on the left side of the divider, we had 6 negative and 6 positive. So we're going to pair those up.
And make sure when you add 6 tiles on both sides, that's what we write down. We go ahead and we braille or we write plus 6 on both sides. Make sure you do that step so you get used to it, writing it down. Because the whole idea is once you understand the concept, we stop using this model. Okay. So we're done removing it, we pair them up. So what did we end up?
We
Librarian,
So you end up with a total of 17.
So we ended up what? I'm sorry, Wyatt, I didn't hear you.
You end up with a total of 17.
Yes. And how do I say that as an equation? So what's on your left side? You have 17 on your right side, but what about the left side?
X equals 17.
So we have a tile of X, the divider is equals, and then 17. Good job. So let's go ahead and work on two-step now. Are you ready to work on two-step equation? So let's work on 2x plus 13 2x plus 13, let's do 2x plus 3 equals 13. Let's do that. 2x plus 3 equals 13. Brianna didn't remove her tiles on the right side. That was clever. So Wyatt's tiles are all chaotic. Oh, you're organizing it now. He always keeps it so chaotic. You're organizing it today. So I can see that you'll model out your 2x's plus 3 equals 13. 3, 6, 9, 10, 11. Wyatt, how many tiles do you have on your right side? Brianna is feeling her tiles, making sure she has 13. All right, do you have 13, Brianna?
Yes,
Okay, so what's my next step?
you gotta isolate the variable. So we have to add. We have
Add 3 negatives.
Good, let's do that. Let's go ahead and add 3 negatives.
to both sides.
Both sides. So they're looking for their red tiles right now. They're looking for their negative tiles and they're trying to add that. And Y just removed his tiles. Oh, and now he's adding 3 more negative tiles to his right side. And he just removed it.
Three. Yeah. Here we go. And now I'm gonna pair them up and move on. Off the board.
So what are you doing, Brianna?
I'm pairing them up because I added -3 to both sides. So now I'm pairing them up and removing them off the board. Or not all of them, but just the ones that I can pair. So we're just gonna move them. Okay. There we go.
So what are we left with right now? At this moment, what's on your board?
Now we're left.
And 10 little green squares.
We have 2x equals what?
10.
Yes. So now what? Now that we have 2 of the x's equals 10, what do you think is my next step?
You would pair them up.
Okay, let's try to pair them up. Yeah. Pair them up equally. So let's try to pair them up equally because we're splitting them. Right, would you like to talk about what you just did while Brianna is working on her model?
What I did was I have 2x, then have 10 on this side. So what I did was I took my 10 and split that in half, which gave me 5. Then I took my 2x's and I split that in half, which gave me 1x. And so what I did was I took one of my x's and paired it with a group of the 5 squares, and I took the other x and put it with the other group of 5 squares.
Okay, so 1x equals one of the x's equals how many? Good job. So my solution is going to be
2x equals
I'm sorry, 2x what?
2x equals 10 equals
I'm so sorry. Wyatt, could you say that again? I didn't hear you.
2x equals 10.
So it's 2x equals 10.
It's 1x equals 5.
1x equals 5. You're right. So 2x equals 10, but then we try to isolate. We're trying to simplify it. But 1x is going to equal
5.
5. And do you understand why? Do you see a model? We have one of the x's, but then when we split, we have 2 x's, but when we try to split it in an equal group, then one of the x's had 5 integers. So it has, that's why it's x equals 5. Do you have any questions before we move on to a word problem?
Nabiha,
Yes.
I wanted just to ask you a question. While you were in this transition mode, there was an earlier question that was dropped into the chat of just asking, have you ever come across a problem for which there were not enough tiles? And the person was wondering if because of that, you might need to order another set. Have you ever experienced that in your teaching?
Well, because we use it on simple expressions, a little bit more intense. Once a student gets the foundation, once they get the idea, it's easy for them to work on a more complex problem. So we can use it on those simple negative problems, but once they understand the concept, like the two-step equation, once the concept is developed, we can work on something more intense, like x plus 100 equals 1,500, because we need that foundation. When the concept is developed, we don't need 100 tiles. Robin, would you like to add something?
Well, and the other thing too, Amy, that I'd like to add to that is that, I thought a great thing to do would, if, APH has that carousel of textures, like you could get textured paper, you could get cardstock paper, and you could create your own additional tiles. Say if you work in an inclusive setting and you have several students that you're working with, you could create some lookalike tiles that you could let every student use. And then you could, if you created them properly, like you could put the Braille overlay on them yourself, Brailling them out on a Brailler. So you could create, if you thought you needed an extra set, I will say there are a lot in the kit. So I think the kit is sufficient, but if you felt like you wanted some more, if you lost some, we included a BRF of the tiles for anyone that's a tactile user in our website today, so they could at least print those out on an embosser and feel and understand what we were talking about today with the tiles. But you could do either way, after you have the concept, move to bigger numbers, let the children see that. Another thing about the tactile tiles that I want to say is, some of our students, when it comes to multi-steps, need a clue. Like, have you ever had a student and you have to say, what next? What next? Using a tool like the tactile tiles is going to help them understand the next without you having to prompt them. We want to make children become independent. That's our whole goal as teachers, is to help them become independent. And while we're saying that, before you move to your word problem, is someone also asked in our chat about brailing the math. Kindergartners should be brailing their math, their numbers. It should start just like their letters start. And I know that, every VI teacher has different trainings and different backgrounds. We want to make sure, whether you use Nemeth Code or UEB, that your children are engaged in all of the math through the textile field. They need to be have access to writing numbers, writing equations. I mean, you really could get this kit and use it with a kindergartner if you wanted to, when you're introducing units of 1s and 5s, but it's very important. There should be no reason a student with a visual impairment, a low vision or blind, is delayed in math because of not having all of their skills. And these two students are perfect examples of that they've been given all the instructions that they needed to get to where they're at. So good job, guys. I've done a great job. I'm sorry, Nabiha.
Oh,
I think that you both articulated that really well. Nabiha, I love the way that you were emphasizing, and this goes to Brianna and White. You get a moment just to kind of take a breather while we chat for a moment. But I want to affirm what you mentioned, Nabiha, about that this is a starting point, and that you use this now, and when you get to more complex, then they are ready, because this tool gives them a foundation. So I know that you had mentioned it briefly in the beginning when you introduced things, but I just thought it was great to go back and be able to repeat that. And then also just that, even though we're preaching to the choir, right? We're all on the same thing, but always being reminded that it's never too early. And I loved the mention about even introducing this product and working with a student that's in kindergarten. I can see how this will move with them. So thank you for letting us have that brief public service announcement and for answering that question. And now back to regularly scheduled programming.
But this helps students process their thinking while they're working on their model. And Brianna and Wyatt were brailing and writing, because Braille is as important as modeling. Robin and I will always talk about how students should always be brailing their work. But they were brailing, they were writing down their equations, they were writing their steps. So at some point, the manipulatives would be taken away.
Mm-hmm. And I think that the way that you are modeling things is brilliant. And I want you to know, Jeff and I are behind the scenes in the chat window keeping up, but you need to know specifically too, Nabiha, that there have been some very encouraging comments put in about what a great teacher you are in modeling for us how to guide students to find mistakes and adjustments that are needed rather than telling them. So I have appreciated your role modeling. Thank you.
Thank you so much. So let's move on to a word problem, because I feel like word problems they're very scary for some reason. Math is scary to start with, and then we have word problems. So are you ready, Brianna and Wyatt? And I did Braille and wrote the word problem out for y'all. It's on your
Yeah,
I think
I got
that's all. Okay. So would you like to read? Wyatt, would you like to read the problem?
Sure.
Brianna, why don't you read the problem?
No, he can read it.
I'll read it. Wyatt spent $20 on his girlfriend. He bought half a dozen roses for his girlfriend. He also bought $8 worth of snacks for her. How much did each rose cost?
Okay, stop. Could you think of some important terms? I'm gonna let you process this problem.
20. We know he has $20. He spent
Good.
$20.
Good. We know he has $20. So I know our equation is gonna look like what?
It's going to be 6x.
But walk me through your thinking process because I think very differently. I started off thinking about 20 for some reason. So walk us through your
Okay.
thinking.
So he has $20. And we know that he spent $8 on the snacks. And we know he bought half a dozen roses. Half a dozen is 6. So, but we don't know, we're trying to figure out how much money he spent on the roses. So 6x for the roses.
And then I'm gonna let Wyatt finish the problem, please.
Okay.
Brianna. So we have 6x because he bought 6 roses. We don't know how many. X represents the cost of each rose, and then what? So Wyatt, I know my total amount is what?
20.
Good. So I know what's gonna be on the right side of the equal sign. So I know everything is gonna equal to
20.
Good. So Brianna started us off. He said 6x plus Wyatt, please write down the equation before you start working on the model. So what's our equation going to be? 6x you bought roses. And what else did you buy, Wyatt?
He bought snacks.
Good.
$8 worth.
Good. So how does your equation looks like?
6x plus 8 equals 20.
Good job. Yes. So let's go ahead and model that out. I know you started modeling it, so thank you for that.
Yeah, I already wrote it down.
Thank you. So I see, what do I see? I see 6 x's.
Yeah.
Someone in the chat said if the set has a model that represents tens or hundreds, I just want to address that. If you have a tile, you can make it represent whatever you want it to represent. Okay, it's not a set rule that this tile should represent X. This tile should represent plus a negative integer, plus a negative 1. It will represent whatever you want it to represent as a TVI. Does that make sense? But I know APH has a lot of products about tens and hundreds manipulatives.
Sorry.
It's a 2-step equation, and Brianna and Wyatt, would you like to walk us through what you're doing?
I'm modeling, so I have my 6 x's. They're like in rows of 3, and then I have my 8, which is like right next to it on the left side of the divider, And I have my divider, and now I'm putting my 20 tiles down on the right side.
And wide have the same exact thing, right, wide?
Yes.
10.
I know 20 tiles take some time to sort it out, especially when you have your negative and your positive tiles all mixed up. It's really hard to.
That's why I
separate.
keep them in the bag.
Wide is making a row of 3 while Brianna is doing rows of 2.
Yeah.
Got it. Okay, so we have our model set out. What's my next step?
Your next step is to isolate the variable.
Yes.
And so you're going to take 8 of the negative tiles and place it over the 8 of the small green tiles.
Okay. Let's do that. Let's add -8 on both sides. So make sure to write that out as well. So we are adding -8 on both sides.
Okay. Two, 3, 4.
So Wyatt and Brianna, they're just putting their tiles, they're putting their negative tiles. Brianna is putting it right next to the positive tiles, and
This doesn't work.
are you struggling, Brianna? So after I finish putting my negative tiles, -8 tiles there, what do I do next? What's my next step?
You want to group them.
Go ahead, do that. Go ahead and finish modeling your equation.
E. Ruby. Go. Okay. Right there. Right there. Wait. Yeah. Go. Okay.
So after we done pairing them up, we make the 0 pairs. What's my next step? What am I left with after I add -8 on both sides? What's my next step? What am I left with?
You are left with 6x equals 12.
Is that correct? Wyatt?
Yeah.
So what's my next step? I'm left with 6x equals 12. Now it's a one-step equation. What's my next step?
Now you want to group them together.
We have to group them what? I'm sorry.
Now you want to group them.
Let's group them equally, yes. And once you're finished grouping them equally, tell me what do you get? What's the solution?
Okay.
So the way Wyatt and Brianna are working is very different. Brianna likes to, Wyatt, could you describe the way your model is looking, please?
Well, what I do is I put the x's near the line, then I gave them like a little space between each other, and I paired them up, like between the line.
The way Wyatt has paired up is his tiles are like are horizontal, and right next to the horizontal tile he has the integers, the ones tile there. But then the way Brianna has paired them up is it looks a bit different. Brianna, how have you paired them up?
I have on each X, so I have like my X's kind of like scattered on the board. And then I put the tiles like split equally touching the X. So like I have one X plus two tiles.
Yes, but then why it's like Brianna said, her X's are all over the board, it's scattered, but why it's like going down. It's a nice little row of going down. And then I know what's going to be my solution. 1x equals 2. Very good. There's 2 of them mashed up, paired up with 1x. Very good. And that's going to be my solution. So what does that mean? What does 2 means? What 2 what? What am I doing with that 2? What does it represent?
Yeah, how much each rows?
Very good. So make sure whenever you have a word problem, always end up writing what it represents. All right, it's very crucial because when we have a 2 written and you go to college, your professor's gonna be like, what's up with the 2? What's that 2? Okay, I know that you know, but you have to write down. So let's go ahead. We're gonna wrap this up, and I do want to hear from Brianna and Wyatt. Like, give me your honest opinion. If we have teachers watching both of you, and they're considering whether they should, have their student use this tiles or not. So be honest, what do you think? What would you like to say to those teachers?
Me personally, I think that these would be really beneficial. So like for me, I understood distributive property, like I had the concept, but I mean, not distributive property, factoring, like I had the concept, but I didn't really get like, I guess why you did it.
Okay.
Until, she said, oh, like split them equally. And then it kind of like having that hands-on experience, for the basis of it, it just made more sense. And I know growing up, especially since for a lot of my younger years, I was in a public school and I had like a TVI, but I didn't have I didn't have a lot of the materials, so it was just kind of like people were talking and I was made to memorize that. And the hands-on experience with Braille, with tactiles, with materials like this, especially for the basis of things, kind of just helps a lot more to understand and really get it stuck in your head, like to where you can actually really understand what you're doing, why you're doing it, how it's done, and kind of, the process.
Thank you, Brianna. I appreciate your honesty. I know it's not easy sometimes to talk about how certain things make you feel. So thank you so much for that. And what about you? What is your experience, or what would you like to recommend to our teachers if they're watching, or parents if they're watching us?
Okay. I grew up in a private school, and most of the time, teachers weren't usually hands-on. They mostly just talked. And usually it went quite fast because They just want you to hold the information in. But with these tiles, even it's very hands-on, so some people are able to understand this easier than having it just said to them. And it's great. It's a great tool. I like it, even though I have vision. It helps me keep organized because I'm one of the people that doesn't like using pencil and paper. I mostly try to keep everything in my head. But with this, it's not something that I want. I like using this rather than just having to hold all the information in my head.
I think that is so great. I just want to interject. I think that Brianna and Wyatt, what you both said, gets to the heart of why this is such a helpful tool. And everybody can see too in the audience of how this is a perfect example of the universal design for learning. But Brianna, I love the way you put into words as well, that it gets to the why and the how, the process. And that is what helped us teachers on the end of watching you work through these problems, to the both of you students, is because we were able to see that process. You were giving the instructions and putting words to what you were doing, and you are matching those words with the actions of moving the manipulatives. And I think that this just really showed that so much. And so I appreciated getting to hear from the heart of you both of what you think.
Thank you, Wyatt and Brianna. Because at the end of the day, we are here to serve our students. That's why we're here. So it's always good to know how the student feels about it.
And I just want to add a kudos to APH, because y'all's research team that puts products together really hit a home run with this. I just think it really is what the field needs so students can have a foundation. So thank you, APH, for this product. And if there's any trustees that are out here, make sure you share this with the teachers in your state. Make sure they understand what a voucher to this is. You heard it from Wyatt and Brianna. It's something that they enjoy using, and it helps develop those skills. So thank you guys. I did a great job.
And then this webinar was really to touch the basics of how to use tactile algebra tiles, but we could make it very advanced, but we just wanted to, make it very simple, just to have those simple foundations. But I don't know if the TVI wants to know the advanced one, you can let APH know, and then we can work on that as well.
I think that, so there was a comment that was from our audience that, every student can benefit from this, just not students that have a visual impairment. And so you can also see these opportunities of how a student can be paired with students that don't have a visual impairment at all and still have equal access and have the exact experience to understand the process. I know that when I think about my process of learning, different early pre-algebra sorts of expressions and how to do that, I would have really benefited from this instead of the pure memorization. Going back to what Wyatt, you had mentioned, that being in the classroom so often, you might be with teachers that just want you to help memorize the information rather than understanding the how. So just a lot of kudos, as Leanne usually says, that are popping into the chat window that I hope is an encouragement to all of you to know that this has been helpful for all of us. And one item that we did not mention that really just needs to have a shout out, the whole reason, this is for all the audience, that we get to be at the foot of watching Nabiha and Robin speak today is because Nabiha is an APH scholar. And that is something that is an honored an honored position that people are called upon through ex officio trustees. And it happens during the annual meeting. And Nabiha was one of our APH scholars. And so, because you can see her natural talent for teaching, we wanted to be able to put a spotlight on that to share out. So this is the reason why we have this today. And she was able to think about what she would want to bring to the audience today. And it was a math lesson. And just thank you very much for being so willing. I know that you poured into your time and effort in creating the content and carefully sequencing what you wanted to feature today, as well as making sure that the students were ready to go. So thank you.
Thank you so much for having us.
Brianna has something to mention.
Yeah, just one more thing. Sorry. But when you mentioned like kids who can also benefit from this, it just brought another thought into my head. A lot of the times as students with disabilities, low vision, completely blind, whatever it may be, in classroom settings, especially in public schools with just like a VI, a lot of the times from personal experience, I know this, we feel separated, kind of like not part of whatever's happening because all the other students have these materials and have paper and whatever in front of them. And a lot of times, like I said, especially in public schools, we don't have that material. We don't have anything to kind of like help us. Like why I said, we just have to sit and listen to them talk and remember everything. And it kind of makes us feel different, like awkward. And so having these materials, having this sense of there's something that can help us, makes it feel a little bit more normal, makes us feel a little bit more part of the class, part of the school environment, just kind of normalizes everything instead of feeling apart and separate from whatever's happening.
Thank you for
I
mentioning.
think that was a great statement. And what I really want to be able to mention with that, Brianna, is that by you stating that, this is a reminder, and just to everybody who's in the audience, that you have the ability of getting these products into the hands of your students. Students don't have to go to a specialized, school for students that have visual impairment. All students can access this, whether you are an itinerant position going into different schools or, if you're in a residential placement. So sometimes getting the word out and sharing with your friends and your colleagues that these things are available, you have the power to do that. And so I could not have spoken it any more brilliant than what you did, Brianna. So thank you for driving that home. And I'm going to have Wyatt mention something, and then I'm going to go ahead and get us closed up with the closing code. But Wyatt, we want to hear from you.
So, adding on to what she said, I went to a private school, and in private schools, they have the right to refuse everything. So when I went to my private school, they usually refuse all of my materials that were used to help me. And so I wasn't really allowed to touch any of it.
And that does show that there is differences in what happens when we are through the public school system and when you are on an individualized education plan. We are glad, Wyatt, that you are in the place where you are now, and you too, Brianna. You have been role models for us so that we can be better teachers and help impact more students. But again, Robin and Nabiha, thank you. Thank you for sharing your talent with us today.
Amy, I do want to add something. I forgot to
Yes.
add that you just have to model this to the students one time. That's it. And then they can just set it up by themselves. The teachers doesn't have to model it every time. This is like a one-time show thing. That's it.
Thank you.